Alright guys, welcome back to the channel and welcome back to another episode of our RPG series. In today's episode we're going to be dealing with heat reactions, and what I'm going to be trying to do here is make it direction based. So we'll see how it goes. If we pull it off, well and good, but we're going to have heat reactions by the end of this episode. So alright, so the plan here is that we calculate our swing direction so that we get the direction of our sword, and then we can apply, when we apply damage, we also follow the heat direction and then apply the reaction accordingly. That is how it's supposed to go. Let's hope we do not have many issues. So the first thing we're going to do is we're going to go into our player controls. We're going to go into our scripts that's in the combat system. We're going to create a script here. We're going to call it the weapon swing direction. I'm going to call it the weapon swing direction. So the purpose of this script is to really just calculate the direction in which our weapon is being swung in. So if we come to our player, let's just hit the weapon. So we do have our weapon scripts here. So even the weapon swing script will go there. Now let's open up this script in Visual Studio. Again, if you're enjoying this series, leave a like, comment down below, show if you're even interested in showing us what you've created so far. Join the Discord, the link will be in the description, and then show us what you've created, and let's discuss more about what we want to do going forward. Alright, so with that out of the way, let's just do something quickly here. We're going to say we're going to have a private vector 3. So it's going to be private vector 3. Then this will be the previous position of our weapon. So we want to be able to calculate from the previous position to the next position what exactly is the direction. So we're going to say private vector 3, but not next position. Instead, we're going to say swing direction, like that. So, well, let's just put a comment here. We're going to say this is to store the position of the weapon, okay, before the swing. Now in our start function, we're going to say previous position is equal to transform.position. So at this point we are initializing, so initialize the previous position to be the position of this word, or of the weapon. Let's say of the weapon. Then what we're going to do now is go into our update function. Let's just remove the comment. We know exactly what the update function does. We don't need a comment. We're going to now say swing direction is going to be equal to, then we're just going to say calculate swing direction. That will be a function which will return a vector 3. So we're going to go down there and now write that function. So it's going to be a public function vector 3 It's a vector 3 function, and then it's going to be calculate swing direction. Okay, now what are we going to do here? So the first thing that we're going to do is to calculate the position of our weapon. So we're going to put some comment here and say calculate the current position of the weapon, and then we're going to go down and actually do that. So it's going to be vector 3, okay, current pose is going to be equal to the transformed position. Then we're going to now put another comment and say calculate the difference calculate the difference vector between the current and previous position. Okay, so we're going to now say vector 3 swing direction is going to be equal to the difference, so we subtract, we're going to say current position minus the previous position. And then we're now going to make another comment here so that we follow it, because it's a bit long, not too long. Update the previous position per let's say update for the next frame. So we're going to come down here and say previous position is equal to current position. Then once that is done, we are going to need a return function. So we're going to return swing direction, but not just return it, we're going to normalize it. So swing direction dot normalized. So what we're doing here is literally normalizing it. So we normalize to get a unit vector like that. So that's our function, that's our swing direction being calculated there. If you know a way that we can improve it, you can let me know, but for now that's it. When we go back to Unity, we will be calculating it right there. Actually, let's make this one public, the swing direction, because we'll need to access it in another script. Yeah, so let's save that. Let's make it public. It will need to be accessed in another script, and we can see the vector there. Nice, nice, nice. The next thing that we're going to do is to go into our script do damage right here. Let's open that script up. So what we're going to do is, inside the do damage script, we've got the trigger script with the trigger function. Below that, we're going to say void apply hit direction. Void apply hit direction. It's going to have two arguments. So the first argument is going to be the character controller, because our character has to be moved. We don't want him to just react but in the same position. We want to actually move the character into the hit direction. So we want to manually move him without having to have an animation which moves the character. So we don't want to use root motion animations. We want to actually physically move the character with a script. So since our enemy character also has an controller script, character controller, I mean, sorry about that, we're going to have that argument, and then the next one is going to be the direction in which we want to move this character. So let's just come to the top here. Let's create hashtag region, and then we're going to say hit mechanics. Then we're going to say hashtag and region. Now inside of hit mechanics, we're going to now say serialized field. It's going to be a float, and this will be the hit force. So how much force are we going to apply to our character? We'll initialize that at 15. If we do not like it, we might change it. 15. Then we'll go down here and say let's actually do another one. We're also going to say serialized field. We're gonna say float again, and this will be the damping, because we want it to be smooth. We want it to smooth out the movement. So it will be, yeah, you will see how we use the damping. We'll put that at 1 for now. That's about it. Let's just rename this for the most variable, the capital letter. Let me do that. Okay. So now we do have the hit force, we do have the damping. What we're going to do is we're going to say controller move. Okay, we're going to move the direction multiplied by the hit force, and then multiplied by the time dot delta time, like that. So we're going to put a comment here and say apply the hit reaction by moving the character to the specified direction. Nice. Then we're going to say direction, right, multiplied by or equal to the damping, multiplied by or equal to the damping. So now we're going to, let's put a comment here so that you understand exactly what we're doing. We're going to say apply damping to slow down the reaction so that it looks smoother. Now we're going to have a while loop. I don't think we've used while loops a lot, but we're going to say while a condition is true. In this case, while direction dot let's see, while direction dot sqr magnitude is greater than 0.01 f. We're going to do something while that is true. So what we're going to do here is we're going to put a comment again. So continuously apply the decelerating force until it reaches a negligible, so something we can ignore, a negligible value. So that's what we're doing here. So while direction.sqr magnitude is greater than 0.01 F, what we're going to now do again is controller move. Okay, same scenario, direction multiplied by the heat force times time dot delta time, and then again we put direction equals to multiply equal damping. Okay, so we want to do that until we reach a value that's very negligible. Then down here, right under the while loop, we're going to say we're going to determine the heat direction based on the direction vector. So now here what we want to do is to have some animations play as well, but first we need to see which animation has to play when, because we do not want a reaction to the right when we've been hit to the left, or a reaction to the left when we've been hit to the right. So now here I want to determine that direction, then using that direction play an animation. So what we're going to say now is float. We're going to say dot forward is going to be equal to vector 3 again, vector 3 dot. Okay, so a dot is a product of two vectors, so we're trying to get the value of two vectors here, and the first vector is direction and then the second vector is the transform of transform dot forward. Okay, then I'm going to say float dot right is going to be equal to the vector 3 transform dot right. Now once we're done there, let's put another comment here, and then we're going to say trigger the appropriate animation based on the heat direction. Okay, so we're going to now say if math f dot abs dot forward is greater than math f dot abs dot right, we're going to put a comment here and then hit forward or backwards. And then what we're going to say is if the dot forward is greater than 0, then we are going to put a debug log heat forward. Okay, then we're going to put an else statement, and then in our else statement we're going to say debug dot log hit backwards. Then we're going to come to our else here. So the else is its left or right movement. What we're going to say is if the dot right is greater than 0, we're going to put a debug again dot log, and it's going to be hit right, and then else, you guessed it by now, debug.log hit left. Okay. All right. That's it. That's all we're going to do in this function. So right in our on trigger enter, because we want our damage to apply, our reaction to happen in here, what we're going to say is we're going to create a new variable up here, serialize field, character controller for our enemy, so E controller. So this is our enemy controller. Okay, then what we are going to do now is, let's just set it up actually, because we're going to need it, is to say serialize field animator. This will be our enemy E animator. Okay, so now we have those two set up. Then what we're going to say is right at the top here, we're going to say E animator is going to be equal to the other game object dot get component in children animator, because remember that the other game object that we're colliding with has the character controller, so that's the dummy, but in the children of the dummy there is the animator. Then we're going to now come into the sword damage issue here. We're going to come right after we say health system dot take damage. We're going to say let's see, what are we going to say here? Okay, so let's say E controller is going to be equal to, we're going to say other dot game object dot get character controller, like that, and then we're going to say vector3, the swing direction is going to be equal to this dot game object, because remember the swing, we're getting the swing direction from this game object dot get component. We're going to get the weapon swing direction, and then what we're going to get from it is our function, which is calculate swing direction, like that. Then okay, we're going to do it like that. Then we're going to go, in fact we do not even have to do it like that. What we can do is, we're already passing the swing direction there, so we can just get the swing direction variable like that, because we're already passing it, so we do not need to call that function. Then what we can say here is the vector 3 hit direction. Ah boy. Vector 3 hit direction is going to be equal to right, it's going to be equal to other dot game object dot transform dot position minus, we're getting the transform position of our enemy, transform dot position of our script, so our sword. And then what we're going to do is let's put this, or this, yeah, let's put this in parentheses so that we normalize it at the end. So we're going to say dot normalized, and then we're going to now say apply hit direction, and then we're going to pass the controller. Then we're also going to pass the hit direction. Now that I think about it, there's nowhere where we're using the swing direction. Where are we using the swing direction? I don't think we're using the swing direction anywhere. Anyway, we'll leave it for now because it's in my notes. Change the way our attack function works. So inside of our combat script, our attack function is going to need our transform. So let's go and change that. So we're going to go into our, I have it here. Do I have to go back to Unity? Can't I just search for it right here? Player combat. So you can see our attack function here right now doesn't have any argument. We're going to give it an argument and say transform transform. We're going to call this target, and then what we're going to do now is, do we actually need this? Because we're already doing it on that other side. Now we don't need this. Yeah, we don't need this. Let's just leave it as is. We don't need that. We don't need that. Let's leave it as is. Let's go to Unity and see what we have. Okay. So we can open up our script here, and when we hit play, we should see it calculating the swing position. You can see that our swing position, or our sword position, is currently being calculated. Then when we equip it, we can alright, target our dummy, move forward to him. Boy. Did my Unity just crash? Alright, so sorry about that. So it seems like the while function was the one that's causing the error. So I'll comment it right now, and if I manage to fix it, I'll let you guys know in the next episode. So you can just comment it out, and then you can go with the rest. It will still work the same. All we wanted is to keep moving until a certain time, but it's not working the way we want it to work. So we could actually try to do the dumping and still. So just comment that out, and you should your reaction should look something like this. I don't know why that while statement is breaking, but we'll move on. Don't have to wait for it. You can see he moved backwards, so that can hit him from here. Oh boy. Okay, I'm guessing he moved but something is blocking us. Why is something blocking us from moving to where he is? So let me just show that again. We hit him and he moved backwards. So we're going to equip. We're going to target him. And you can see he's moved backwards. Again, he's moved to the left. You can see those reactions there. He's moved to the left again. He's moved to the left again because we keep hitting him to move to the left. So that's how it's going to be working like that. But now we're remaining with one part, which is to animate this guy. Okay, again, I'm going to leave these animations in a link in the description. You can get them. These are my personal animations, so you can use them. I think you can use them, maybe not, because they're paid for, but yeah, we will see. So we've got the hit back, we've got the okay, we've got the hit left, we've got the hit right. So what we're going to do now is to come to our enemy here. So he's using the same humanoid controller as our main character. Yeah, let's for now let's keep using the same one. So let's come into the come here, then we'll come to the character hit reactions. We'll drag in these three: hit right, hit left, and hit back. And then we'll be making the transition back to there, back to there, and back to there. So if you hit him, once he reacts, he automatically go into the attacking state. Okay, so they all have exit time, so they have to play all the way. Now, where we were playing these animations, when we hit forward here, we're actually going to play the hit back animation. So we'll go back here into Visual Studio and we'll play the hit back. So let's just look at it again one more time. Alright, so we're going to come here and now say the E animator dot play, and we're gonna play the hit back. So you've hit him from the front, he should be hit back. Okay, then we're going to copy this, and then on the hit right, play what is it called, hit right. So instead of hit back, we'll play hit right, and then we'll play the hit left animations. So once we hit him, those animations will activate, and then depending on the direction, then you'll play that animation. Let's just try to come on. There we go. Target him, and then you see that he's played that animation, and he does hit left, keeps playing the hit right at that point. Climbed on his collider, but anyway, you can see that our heat reactions are working, because at the bottom here on the debug log you can see I might have to make our weapon a bit longer. It's a bit short. It requires us to be very close for us to hit. There was a hit back animation, then the hit left animation, and so on and so forth. Yeah. So the next thing that we're going to do, since we have these heat reactions, is to give him some sensors, so like sight and also some patrolling, so that he's not just standing there. Then we'll begin to work on his behavior. I should have changed my animations in the next episode, so I might show you the animations I'll be using. Then you can get them from the asset store or from wherever you get your animations. It doesn't have to be the same animations. You can use your own animations. I'm going to get some animations for the attacking so that we have better animations. But yeah, from there, if you have your own animations, just use them, and we'll work on smoothing out everything. But you can see we have the heat reactions, we have it working the way we want it to work. Because what we wanted is, let me just show you one more time. What we wanted is when we hit him back, he reacts accordingly. He doesn't play a weird animation. You can see that was hit left and he played the hit left animation, and then the hit right animation, and then we kill him. Alright, we can see that that health bar is also not updating correctly. We might need to change it so that it updates correctly, because right now I think the challenge that we are having is that our collider is ever on. So when we are even just walking and we collide with him, it takes health off him. But what we want is only to be applying the damage only when we are attacking. So what we're going to do in the next episode is to make sure that our collider on our weapon is activated only when we attack, and once the attack is done, it deactivates, so that we can attack again and it activates again. So that's what we're going to be doing in the next episode, as well as giving him some behavior so that he can patrol around and do the likes. Anyway, if you enjoyed this episode, leave a like, comment, subscribe if you're new to the channel. Do all that great stuff. It really helps the channel out, and we've been growing really quickly, and that makes me so glad that so many people are finding the channel and actually enjoying the content enough to subscribe. I appreciate all the support that each and every one of you is showing. I'll keep trying to bring out the content, but I want to only bring it out when I'm sure that it's I've tested it enough. So yeah, I have tested the patrol function, so that's why I'm saying that one is going to be coming out next, and then we would probably tackle him attacking or him following us, him investigating, and us being able to take him out stealthy before we leave combat for a bit and go deal with something else before we come back to the ranged and mage combat styles. So if you enjoyed this episode, leave a like, comment, subscribe again, and I'll see you all in the next one. Bye bye.